In this tutorial, let's go over the basic workflow of the FluidLab add-on. The basic difference between Blender's MantaFlow and FluidLab is that Blender's MantaFlow is based on flip simulation, which requires a domain. For the FluidLab, this is based on SPH system of Blender, and there is no need for a domain. Let's see how to install this add-on. Once the add-on is downloaded from Blender Market, we can head to the Downloads folder, and here's the add-on. And in Blender 4.1, let's go to Edit, Preferences, click on Install, and we can point it to the add-on and then click on Install Add-on. And once the add-on is installed, here we can point the required directories under Dynamic Paint. We can point it out where we would like to have the cache path for the Dynamic Paint caches and also the export path. And for rendering, we would also like to give a flipbooks path where we can have the viewport previews. Here's the layout of the FluidLab add-on in the end panel. Here we have fluid groups, and in each fluid group, we can have many fluid emitters. And here are the main modules of the add-on, and here we can find the settings of each module. Here's a simple scene setup with a plain mesh and a few rocks with a nice HDRI. So let's add an emitter, a UV sphere. So this will be our fluid emitter. Let's add collision to the mesh and the rocks so that the fluid particles, when emitted, are going to collide and interact with these surfaces. So let's select the plane mesh and let's add a collider. Let's add a selection collider as this is selected. And here are the parameters for the collision. And let's just refresh the damping because sometimes the damping needs to be refreshed for it to work properly. So let's get the damping to 1. And let's increase the friction to something like 0.1. And let's also introduce some random friction, something like 0.07. And we can similarly add collision to the rocks by selecting all the rocks and then adding a selection collider. Or since these rocks are in a separate collection, we can just add a collection collider. Let's add a collection collider and let's add rocks. So this is going to add collision to the rocks collection. Now let's do the same thing again. Let's refresh the damping and let's increase the friction to something like 0.1 and let's increase the random friction to something like 0.07. Perfect. Now let's select this UV sphere and let's add a new group. And here we have geometry and InFlow. If we select geometry, then the fluid particles are going to be emitted from geometry once. If we select InFlow, then there would be continuous emission of particles for the defined number of frames. So for this example, let's consider geometry and click OK. And let's add an emitter in this fluid group. Now with the default settings, with a resolution of 20, let's just play the simulation. So this is how it's going to look like. Now, in order to get more detail out of the simulation, let's increase the resolution to 40. Now here we can just play the animation so that the simulation starts running. Or what we can do is we can first bake the simulation. So let's just press this icon here to bake the simulation by selecting the emitters. And once the simulation is baked, we can play the simulation in real time. There we go. Now here we can change some of these parameters. Here's the size random, where we can give random size of the particles during the simulation. Here, the frame start and end. Here we would like all the particles to start emitting at the first frame itself. So we would like to give the frame start and end as 1 and 1. And lifetime is the lifetime of the particles, which is going to be the entirety of the simulation. And we'll talk about distribution and the soft start and end in the future tutorials. And we can also give the particles a starting velocity. Let's say we would like to give the particles a starting velocity of 2 meters per second in the y direction. Let's first free the bake by pressing this icon here. And let's bake with the current parameters. Let's play the simulation. And there we go. So this is the simulation. So let's use this to add a mesh. So here we can head to mesh and let's add mesh. And in order to add mesh, we need to have the simulation baked. And since we already have baked the simulation, we can directly add a mesh. And here we go. This is with the default settings. So we can adjust the mesh parameters a bit. So for that, let's head to the wireframe view. And let's increase the resolution of the mesh by decreasing the number in the voxel resolution. Let's change this to 0.03. Now we have more resolution of the mesh. And let's increase the smooth to something like 10 to have a smoother mesh. And let's increase the min max here so that the mesh is slightly larger than the particles. Let's say 0.07. Maybe 0.06. Looks good. Now we can get back to the solid view. And here's our mesh. And if you don't want to see any particles, fluid particles, we can just toggle the visibility here. And now that we have the mesh, we can add a shader. And under assigning tab, let's assign a shader for this mesh. And when we click here, we have option to add all these different types of shaders. And let's add a water shader, set material. And here are all the parameters for the water shader. Let's get to cycles preview. And here's the shader. Cool. Now under mesh, we have motion blur as well. And when we render a test frame, we can actually see the motion blur. Here we go. Here's with the motion blur of 20. And we can also increase the motion blur, let's say to something like 50, and test render a frame. And here's with more motion blur. Now let's take a look at an InFlow emitter. So let's add an emitter, UV sphere. Let's scale it down a bit. And let's add a new group. And here, let's choose InFlow. And let's add an emitter. And here are the basic settings in the emission tab. Here, the particles are going to be emitted from faces. And here's a count and the size. So let's run a simulation with the default settings and then take a look. So here's the simulation with the default settings. And let's say we would like to reduce the count to something like 5,000. And let's take a look. Here we can see that there's not much interaction between the fluid particles. So the simulation is not going to give a very good result. So we need to increase the size of the particle if we reduce the count. So let's say we increase this to something like 0.1. Now because of the size of the particles, there is interaction between the particles, so the simulation is going to give a good result. So that's the relationship between the count and the size. The lower the count, the larger should be the size, and more the count, the smaller the size for a good simulation result. So let's change the count to something large, like 75,000, and let's reduce the particle size to something like 0.025, and let's leave the size random at 0, and let's have the simulation emit particles for 100 frames and lifetime of 250 frames. And here, let's take a look at the simulation first. And let's bake the simulation, and then we'll take a look. And let's play the simulation. Looks good. And let's free the bake by pressing this icon here. And let's increase the y velocity to have the particles a starting velocity. Let's say 2 meters per second. And let's bake. So that's how we give the particles a starting velocity. All right, let's get this back to 0. And let's bake the cache. Actually, we need to free the bake before we bake again. Cool. Perfect. Now let's move to the physics tab. Under physics tab, we have Timestep, subframes, and other physics parameters. So let's first take a look at the Timestep. So here, if we decrease the Timestep value, then the simulation would look like a slow motion simulation. So let's say we would decrease this to 0.01. Let's free the bake and let's bake the simulation. Let's take a look. So this is how we can get a slow motion look of the simulation. And this actually also gives something like a large scale look as well. Cool. And if you would like to appear much faster, then we can increase the time step. So let's free the bake. And let's bring the time step back to 0.04. Now let's take a look at the stiffness value. So if you would like the fluid to behave something like oil, then we can reduce the stiffness. And the fluid simulation is going to be less chaotic. Let's bake the sim. Let's play the sim. So we can see that this is much less chaotic, and this is more like oil. So that's how we can work with the stiffness to make the sim more or less chaotic. So let's say we would like the fluid to behave something like honey or more viscous fluid. Then we can increase the viscosity to something like 5. And let's free the bake and let's play. And let's also refresh the cache, because I think the previous run, we didn't bake. If the sim has not been baked, but the frames are in the cache, then we need to hit a refresh cache. If the sim is already baked, then we need to free the bake. So that's how we use these two icons. So now with the viscosity of 5, so as we can see, the fluid is more chaotic. So that's because of the subframes. When we increase the viscosity, we need to increase the subframes. So let's increase the subframes to something like 8. Now the simulation is more stable. So now that the frames are in cache, let's use this icon to have the current cache to bake. So now the simulation has been baked as well. And here's with the more viscosity. So that's how we can work with these physics parameters. Cool. Now let's say we would like to use this sim and then add a mesh to it. And then let's add something like honey to the mesh. There are a few more advanced physics options, and we'll take a look at them in the future tutorials. Similarly, the springs and animation, we'll take a look in the future tutorials. Let's move to mesh. Here, let's add a mesh. And we have one emitter. So let's add a mesh. And let's say we would like to work on the parameters to fine tune the mesh. Let's go to the wireframe view. Here, let's increase the resolution of the mesh by decreasing the voxel resolution. Let's say 0.03. There we go. And let's increase the smooth to something like 10. And let's increase the min max just a little bit so that the mesh is slightly larger than the particles. There we go. That looks good. Now we can get back to the solid view. Looks good. Now that we have the mesh, well, let's go to the shading module and let's go to the assigning tab for this mesh. And let's assign a material, which is honey. And let's set material. And here are all the parameters for the shader. And let's head to the cycles preview. And there we go. We can make the flow more laminar and honey-like by using the resolution option in the emissions tab of the fluid settings, which we'll take a look in a bit. Now let's take a closer look at how to use FluidLab for viscous fluids. So let's add a plain mesh this time, and let's reduce the scale a bit. And let's add a new group, and let's add InFlow to this plane, and let's add an emitter. Now here we have been using the count under emission. So let's change this to resolution. So if you look at the manual, when we use resolution, this generates a laminar flow and it will always emit defined number of particles in each frame. And it's also important to note that this method only works with a plain kind of emitters. Now with the default settings, let's take a look. So let's head to the physics tab first, and let's reduce the Timestep to slow down the simulation a bit and increase the viscosity to something like 10 and reduce the stiffness to something like 0.1 and then increase the subframes to something like 15 because we're working with viscous fluids. And let's take a look. Already we see that it's behaving like a viscous fluid. Cool. So these are some of the settings we can use for viscous fluids. Now, if we take a look at it, here we can see that some of the particles are midway through the collider. So if we don't want this to happen, then for highly viscous fluids, we can actually use this size deflect option. Now let's refresh the cache and let's bake. Cool. Now when we take a look, here we don't see the particles anymore. So these particles stay on top of collider. So that's the advantage of using size deflect. Now let's make some changes. When we go to emission, we can increase the resolution to something like 500 and reduce the size to something like 0.03 and also give it a z velocity in the negative direction. So let's say -2 and let's free the bake and let's bake. All right, let's play the simulation. There we go. Looks good. Now let's have the current cache to bake. Then let's go to mesh and add mesh. And let's add mesh to the plane emitter. And let's get to the wireframe view. And let's decrease the voxel resolution number to get more resolution of the mesh. And let's smooth it out to something like 10. And let's increase the min-max number a bit so that the mesh is slightly larger than the fluid particles. Let's say 0.07. Looks good. Solid view. Let's play it again. There we go. For this, let's add a shader. Now under shading module, let's go to the assigning tab and let's assign honey and set material. Now under cycles preview, and there we go. Cool. Let's save the file. And we can also make it a little more interesting. Let's go to mesh. Let's delete the mesh. Let's go to fluid settings and let's delete the bake. And let's get to the plane and let us insert a keyframe for the rotation at frame 1 and at frame 100 Let's toggle the viewport for the emitter so that the emitter is not gonna emit particles. Let's go to frame 100. Let's go to the Z rotation and let's increase this to something like 360 and insert a keyframe. So the emitter is going to rotate. And let's just change the interpolation mode to linear. Perfect. Now let's enable the viewport and let's play the simulation. So we would have a nice, interesting simulation. And let's have the current cache to bake. And let's play. Cool. Now let's add a mesh. Now let's assign a material. Let's choose honey. There we go. So that's how we work with viscous fluids using the FluidLab add-on. In this tutorial, while making changes to the emitter parameters, we actually deleted the mesh, but we don't need to delete the mesh if we are working on the same emitter. As long as the emitter stays the same, we can just toggle the viewport button here so that the viewport for the mesh is disabled. And then we can make any changes that we want. For example, let's say we would like to change the viscosity from 10 to something like 5. Then let's bake the current cache. Right, let's take a look. This is with the reduced viscosity. And now that the sim is baked, we can actually head to the mesh module and then just simply toggle the viewport back on. And this would enable the mesh. Now let's see how to duplicate the fluid emitters in the fluid group and also how to use the global local setting for the emitters. Let's add a UV sphere. Let's add new group. Let's add geometry. And let's add an emitter. Now let's take this emitter, and when we press the down arrow here, we have duplicate emitter. So let's duplicate the emitter. All right, so now we have 3 emitters. So let's take a look. There you go. This is the other emitter. So we have 3 emitters. Cool. This is with the default setting. Now let's say we would like to have individual parameters for individual emitters since these emitters are duplicated. So whatever changes we make here are going to be applied to all the emitters. Like for example, let's say we want to edit the start frame, which is going to be, let's say, 20. Now this is going to affect all the three emitters because they're all linked. There we go. So let's say we would like to delink these emitters. Let's see how we can do that. Let's get this back to 1 and 1. Let's say for the first sphere, we'd like the frame start and end at 1. And for second sphere, let's say the frame start and end, we would like 20. So first, let's click this icon to change the setting from global to local. There we go. Now let's change this to 20. And similarly, for the third emitter, let's click this delink icon here. And then let's change this to 40. Now let's take a look. There we go. Perfect. And while we're doing this, we can actually scroll down, and here we can change the viewport display to material and then give different material to each emitter. So for the first emitter, let's give it something like blue. And for the second emitter, let's give it something like red. And for the third emitter, let's give it yellow. So let's take a look. There we go. Now we have three different materials for three different emitters for the viewport. Now let's change a few more parameters and then take a look. For the first sphere, let's say we would like to keep the default settings. For the second sphere, let's delink the physics tab and let's give it a viscosity of 5 and also delink the integration, and let's increase the subframes to 8 because we increase the viscosity. Now for the third sphere, let's delink the integration and give a time step of 0.02. Now let's take a look. There we go. That's how these work. So that's how we can use the global local settings. Even though we have duplicate emitters, we can actually link and delink these things. And similarly, if you would like to link back the settings again, then what we can do is we can just press this icon, and now this will be a global setting. Now let's say we would like to add a fluid interaction. Now as we can see, there's not much fluid interaction between these three emitters. They're behaving independently. There's no interaction here. So we can actually add this fluid interaction. Once we go to fluid interactions module, we can add an interaction between these three spheres. There we go. And here's the interaction. Let's take a look. There we go. There we go. We can actually see the fluids interacting with each other. So these are some of the basics of how we can use the duplicate emitters, local global settings, and the fluid interactions. And we're going to take a look in more detail in the future tutorials. In the future tutorials, we'll take a look at the rest of the main modules, and especially the dynamic paint, where we can actually create wet maps as well. Hope you enjoyed this tutorial. Thank you, and stay tuned for more tutorials.